It is always there, even when you can't see it. Hiding in the heart of our own galaxy, a monster sleeps. 26,000 light years from where you are right now, Sagittarius A star waits. It is 4 million times the mass of our Sun, compressed into a point of impossible density. We look at it through our telescopes. We study its physics. We give it names. But we have never truly understood it. Because to understand a black hole, you can't just observe it. You have to experience it. And so we are sending you. This is your journey, a one-way ticket. You are an astronaut floating in the void. Your mission, to explore the boundary of human knowledge. Your ship is nearby, a safe anchor in the darkness. From this distance, the black hole is beautiful. It doesn't suck. It doesn't pull. It simply is. It follows the same rules of gravity as anything else. You could orbit it forever, just like we orbit the sun. You are safe until you're not. A malfunction, a stray micrometeorite, your tether snaps, your engines are dead. You are no longer orbiting. You are falling. You are now in the accretion disk, the glowing, swirling ring of superheated gas and dust. It's beautiful, a cosmic hurricane of light, but you are falling through it. The friction is immense. Your suit is screaming. But you survive. You pass through the disk. And now you are in the quiet, the final silent void between the ring of fire and the circle of black. You check your communicator. You call back to your ship, to your crewmate, Anna, who is watching from a safe distance. "I'm falling," you say. "Pull me back." Anna's voice comes back, static-laced, but calm. "We're trying, but you are slowing down." You look at your own dashboard. Your velocity is catastrophic. 50,000 miles per second, 100,000. You are accelerating toward the speed of light. But Anna's voice says you are slowing down. This is the first great monster of the black hole. Not gravity, time. This is Einstein's great prediction. As you fall deeper into the gravity well, time itself begins to stretch. For you, seconds are still seconds, but for Anna, watching from the outside, your seconds are becoming her minutes, her hours, her years. You are falling, but to her, you are becoming a ghost. She watches as your image slows. Your frantic waves for help become a single frozen gesture. Your light shifts to red. You become a permanent frozen reddish statue, painted on the edge of the void for an eternity. She will watch you freeze for the next 10,000 years until your image finally fades. But that is what she sees. That is not what you experience. You are still falling. You reach the line. the event horizon, the point of no return. You brace for impact, for a wall, for sound, for anything. Nothing. You pass the event horizon as if it wasn't even there. It is not a wall. It is not a surface. It is simply a line in space-time. A line defined by one simple, terrifying rule. Everything can cross it in. Nothing can cross it out. You are now inside the black hole. You are the first human being to ever see this. And the view is not what you expected. You look up, back at the universe you just left. It is no longer all around you. The light of 100 billion stars is now compressed, distorted, blue-shifted. The entire past, present, and future of the cosmos is now a tiny, bright circle of blue light above your head. It is the only exit visible, but you cannot reach it. You look down. In every other direction, there is only darkness, a perfect, absolute, crushing black. And in the center of that black is the singularity, the heart of the monster. You cannot see it, but you know it is there, and you know you are falling toward it. Because here, inside the black hole, the rules have changed. Here, down is not a direction. It is an inevitability. In this place, the singularity is not a place. It is the future. Your future. You are falling toward a stellar mass black hole, one that's about 10 times the mass of our sun. And you begin to feel a pull, a stretch. You look down at your feet. They feel heavy. This is the second great monster, tidal forces. Gravity, it turns out, is not uniform. The black hole is pulling on your boots more than it is pulling on your helmet. And the difference in that pull is growing exponentially. At first, it just feels like you're on a very uncomfortable rack. Then the pull is 10 Gs, 100 Gs, 1,000. Your suit's computer flashes a warning, hull integrity failing. You look at your hands. The atoms in your gloves are being pulled apart from the atoms in your fingers. This is spaghettification. It is the most violent death the universe has ever conceived. The tidal forces become stronger than the molecular bonds that hold you together. Your bones snap, your muscles tear, your skin rips apart. But you are not just torn. You are stretched. Your body, your ship, your very atoms are drawn out into a single thin glowing stream of plasma, a strand of cosmic spaghetti, thousands of miles long. You stop being a person, and you become a process. You die, of course. You die long before you are fully torn apart. But your atoms, your information, they continue the journey, a glowing filament of matter screaming down toward the center, accelerating to near the speed of light, until finally you hit the singularity, and you are gone. This is the terrifying reality of physics. If you want to continue exploring the most extreme and fascinating corners of the universe with us, take a second to hit that subscribe button. We publish new journeys into the impossible every single week. Or are you? That journey was to a small black hole, a stellar mass one. But what if your engines failed near a supermassive black hole, like TON 618, a monster 66 billion times the mass of our Sun? So let's restart the simulation. You are falling again, but this time toward the giant. You are falling for weeks. The event horizon is a shadow that fills half the sky. You cross it, and nothing happens. You feel fine, no pulling, no stretching. Why? Because this black hole is so enormous, its gravity curve is gentle. The difference in pull between your head and your feet is nearly zero. You have survived. You are inside a black hole, alive, and you are coasting. You could live in here for hours, perhaps even days. What would you see? We don't know. The laws of physics break down here. Time and space are interchangeable. Maybe you would see the light from other stars that fell in with you. Maybe you would see nothing at all. You float in a strange, dark, quiet new universe where the only rule is down. You are alive. You are comfortable. But you are still on a one-way journey. The tidal forces are not gone. They are just waiting for you down at the center. You will live. You will explore. And then, inevitably, you will be stretched into a single, silent strand of atoms. It is not a violent death. It is a gentle, inevitable end. This is the ultimate truth of the black hole. It is not a portal to another dimension. It is not a wormhole to another time. It is a one-way street to the end of physics. It is the place where time itself stops, a place where matter is compressed to a point so small it no longer exists. But what about you? What about your information, your memories, your life, the physics that defined you? Is it all just erased? That is the information paradox, a mystery that haunted Stephen Hawking for 40 years. And that mystery, that war between the giants of physics, is a story for another time. But what do you think? If you were the astronaut, which fate would be more terrifying? The quick, violent death in a small black hole, or the slow, lonely journey into the giant one? Let us know in the comments below. Thanks for watching.